Hello folks, I happen to be on a time limit, so let's get it started. My name is Victor, and here is my final NLP project, which I have mostly censored, but will reveal gradually for cinematic purposes. It's a crossword generator, because I really like playing crosswords. The idea is that given the proper training data, we can specify a width and height, and get back an original crossword with a filled-in grid and clues to boot. But before we can get to filling in the crossword with letters, we need to talk about the board. Like, without the words, just walls and blanks. Most papers that I've read on crossword generation just kind of pick out a pre-made grid to use in the final product, but I had a demented idea that ended up getting used in the final project. You know how n-gram generation takes a look at the last n-1 tokens and creates a probability distribution to pick out the next token? Well, what if instead of generating tokens, you were generating walls and blanks in a 2D space, surrounded by stop tokens on all sides, and the moving window was of size n by n? You could pick out the next token on the bottom right of the window and just move across the grid from left to right, top to bottom, until it was all done. A cool generation model, except for the fact that it completely breaks half the time. The model could generate that, and then just be left in a dead end, because dead ends like that don't exist in the training set of good boards. So I added a hacky restart case, and the board generator became a sorry excuse for an n-gram implementation. However, it's still really good at generating novel boards, so we have our foundation now. Next, what are we putting into the blank spaces? It sure as hell ain't English letters, because this project is like the only time I get to nerd out about linguistics, and I'm also really trying to secure those novelty points. So, the crosswords are in Japanese. Which may confuse those of you who know how Japanese works and have never played a Japanese crossword before. Long story short, Japanese uses 3 different writing systems, all very heavily. The first 2, hiragana and katakana, just represent the sounds of the language, the base phonological units like ka or to. Everything in Japanese can technically be written out using hiragana or katakana, and the 2 represent the same pool of sounds, so mapping one to the other is trivial. What is not trivial is the kanji transition, because there are thousands of kanji. Japanese doesn't have spaces, so I'm grateful that kanji exist when reading Japanese, but not when I'm trying to transliterate Japanese sentences. So, we get a library to do it for us. Thank you, Juman. Theoretically, our clues can now be filled in the blanks, and the hiragana that goes in the blank is what gets put in the crossword. Now it's just a matter of picking our dataset. I would take from news sites, because that's a lot of good data, but someone did exactly that in a research paper before, so that's low-key cheating. Taking from example sentences and online dictionaries solves the plagiarism problem, but that's like in the top 1 most boring datasets of all time, so no. Using anime opening theme songs solves the plagiarism and novelty problems, but I have neither a high enough number of anime shows watched nor a low enough amount of self-esteem to include anime in the final project of my undergraduate career. The lyrics to my top 32 favorite anime openings were used for the word pool data. If it was on MusicSmash.com, it was getting dropped into the data document. So now we've gathered all the publicly available data we need to make crosswords, leading us into where the actual model applications happen. We're going to be doing a case study on 2 models, generating 6x6 grids, and evaluating them on how well the resulting crosswords turn out. First, these models require training data to know what a good grid looks like. I wrote another regular algorithm to generate crosswords given a board layout, however I have neither the video time nor personal energy to explain it, so just trust that it works. The important part is that we have grids to work with. The first model we'll be looking at is a decision tree model. You know those complicated if X do this, otherwise do this flowcharts? Imagine your model is trying to create and wire a giant flowchart on the fly while training. That's what this is. If you create a forest of decision trees, they are notably good at image completion, so why not apply them to another 2D task? The second model is a k-nearest neighbors, or just KNN, classifier. It uses supervised learning to detect patterns in input data that result in particular outputs. Again, good at image completion, so what could possibly go wrong? Entirely to be expected, because this is like trying to carve a marble statue with a shotgun. These aren't going to make viable crosswords. Not only is encoding the exact guidelines of crossword correctness near impossible at this level, but notice how each value in the output matrix here is a pixel, a grayscale value between 0 to 1 or 0 to 255 or whatever. It's a gradient, and the difference between 34 and 35 for images is negligible as long as the predictor is close. I was encoding each kana character with a number. The difference between 34 and 35 was the difference between this obscure character that did not appear in the dataset at all and the particle for direct objects. These findings may incentivize the intelligent to seek out certain other classifiers with argmax capabilities, but I want to die on this hill just out of curiosity. So, instead of generating the entire board at once, I went cell by cell instead. I encoded the locally relevant information for a cell into a new input format. I also turned each cell into a one-hot vector across all the possible contents of a cell and just smashed the vectors together. Let's see how the models did over 100 iterations each. I consider this a win. That many words and decision tree generated grids being in our dictionary is astounding to me, and it kind of makes sense that Kanan failed. The way that it groups similar labels together seems very unfit for this task, but the point was to compare and contrast the efficacies of different models, not intended for this use case in the first place, so all is cool. In conclusion, I'm tired. But the concept of this being my final project is funny as hell, so whatever.